My name is Phillip Heckinger. I am a technical art director at Microsoft. For the last 6 years, I've been working on HoloLens and Windows Mixed Reality. I wanted to talk today about what is tech art, how does it empower teams, how does it accelerate teams, and then also give some behind the scenes on some of the different things that we've used tech art to do across the last 6 years. There's a little too much to cover in 20 minutes, so I'm going to keep it down to just 1 or 2 items. For example, what is a tech artist first? A tech artist generally is a role in video games that sits between design art and code. They're usually somebody who has an art background, but they know how to program. They fall generally, I like to say, into 3 categories. There are animation tech artists that tend to build rigs, pipelines. They would do something like some of the Coco character work. There are graphics tech artists who tend to build shaders. They do performance optimizations, memory, things like that. And then there are also pipeline tech artists who build tools and pieces that will help accelerate the team. It might be in your engine. It might be in your pipeline. It might just be processing assets. A lot of times you'll see tech artists be visual effects artists, doing simulations, different things like that too. A lot of fun stuff. To help with that, help illustrate some of this, I'm going to talk about HoloStudio and RoboRaid. These are HoloLens products that we shipped. I worked on both of them with the team. HoloStudio is a creation app where you can take geometry, put it in your space, build different assets out of it, colorize them, put textures on them, save them to disk, share them with friends. RoboRaid is a game where you're playing in your room. Robots are busting in through the walls. You're shooting them, shooting the robots, shooting holes in the walls, and experiencing that kind of space. So HoloStudio. This was very early on in the HoloLens time frame. We were probably 4 or 5 years ago, so we weren't really sure what was going on with the platforms at the time. There wasn't a lot of phone products to compare to, so we had to go through and figure out what can we afford. We didn't really have specs for how much the tracking system was going to cost, the display system for performance, not money. So we were figuring out what is left over for the product. What can the team afford? So we went through, the tech artists took the hardware, we spent a lot of time trying to figure out exactly what the engine could run on it. And we came out with what we called the rule of 200. So we worked with the design teams and said, look, you can afford 200 draw calls, 200,000 verts, and 200 megs of memory. This was just a general guideline to them. It allowed them to go into design situations, prototypes, and know whether they were going to be in the realm of success. And this is really important in a team for a tech artist because it massively will reduce your team's burn rate at the end. Too often I've seen products fail where they're shooting, not really keeping track of what they can afford, and then they end up having months of time trying to make it work at the end, and you end up cutting features that you're really proud of. So this was really good for the teams. Nobody landed exactly in the 200 range, but they all ended up generally around there, and they were able to really save time, produce better products, focus on the quality of their content or their design, and keep moving forward. Once we had done that, traditionally a tech artist on like a game production would have tons of other work to do. We'd be working on character pipelines, weapon pipelines, environment pipelines, working on vehicles, new shaders, fancy shields, all sorts of different things. We didn't really have that in HoloStudio, so we kind of sat down and said, what do we get to work on? What's the most important thing that we could do? And for us, it was improving visual quality. So we said, what about ambient occlusion? This is effectively phone performance. You can't do ambient occlusion on a phone. Nobody really can. It's not affordable. It's not worth it. You have to run at too high of a frame rate, and you have to keep too many things going at the other times. So it was a great kind of challenge and a little bit of a crazy challenge for us to go through and do. We found a way. It's slightly common, but also uncommon. It was vertex color. But the difference is we do it in real time. So we're not going through and painting these before. This is live, interactive for the user. So somebody can take a piece of geometry, grab it, move it over, paint it red, and then the system would recalculate. It would go through. It had a little bit of a delay, but in this case for HoloStudio, it was perfectly acceptable because you don't really need exact per frame feedback. You just need your object to update. You need a nice little bit of polish. So to do this, the tech art team went through and prototyped it. We wrote all the code for it, any shaders or anything else that we needed, presented it to the team. We had art direction sign off, we had code sign off, and then we handed it off to the devs to implement into the final system. What the devs did then is they added a few different kind of data hierarchies to accelerate the system, which is, good, faster is better. But ultimately, when I looked at the final code, it was the core rendering chunk was exactly what the tech artist had written. So we went from the idea to the prototype to the presentation to the actual thing shipping, and we had final code that was in the product. The other product I had mentioned was RoboRaid. So RoboRaid was a video game, as I mentioned. You're in a room shooting robots. They're busting through the walls. It was a good example of moving in your space. It was supposed to get you to move around, use your hand, look in different directions, stand up, kneel down, all sorts of things. Nice little product. And one of the problems that we helped solve on this was if you're shooting robots in the space in your room, no problem. That's relatively straightforward. But if they're busting through the walls, you have a little bit of a problem. You want to see what's in the wall. And then the deeper problem goes, if you want to shoot holes in the walls, see stuff busting through walls, and then walk behind the wall, what do you see? And there's a couple ways that this can be solved. And in a normal situation, you might just stop the user from going there. There's some weird things about how the HoloLens renders where you could render a black box around it and the users wouldn't see it, but then they could walk up and put their head in it. So on the left, we have the surface reconstruction, the SR mesh. And then on the right, we have an example of where something's busting through the wall. Now this little triangle object, or big triangle object that's busting through the wall, actually goes back probably a good 6 feet. It goes back quite far in the room. So if you walked around, you'd see a giant mesh sticking out. Like I said, we couldn't cover it in things. So what we ended up working with the devs and developing was basically a quad. And it wasn't a stencil. It was more of a pre-detection where we would say, OK, are you looking at this side of the quad or the back side of the quad? And then we would decide what to render. We did this on a vertex shader instead of a pixel shader. So it was a good collaboration of figuring out how do we do something cheap? How do we provide a new technology that's very robust, stable? And then back to the original thing is that it empowered the design and art team. They could put anything they wanted in there, and it would work. So it was a nice little system that TechArt helped push forward. Good, this shows up okay. I was worried about some of these slides not showing up great on our projector, so hopefully you can see everything correctly. But this was another great thing that we pushed on RoboRaid, which was how do we take our UI? We had kind of a glowy, hologrammy, emissive UI system. And how do we make it so it's very professional? How do we take that on such a low-power device and make it look great? We started off with solid geometry, which is everybody's go-to for lines and circles and whatever they want. And you can see we have this heavy aliasing around the edge. This is very zoomed in just to show off the artifacts. The next step you could probably do is traditionally go to a transparent edge. So the second one is transparent edge, but you can still see there's some mipping, there's some aliasing edges. And what we landed on was this SDF transparent geo. So SDF is signed distance field. And it's not actually an SDF. This is a variant of it that we created for ourselves, which handles SDF in a different way. And it's technically kind of not even really an SDF, but it's the same concept. So if you're looking to do something like this, that'll help get you in the right direction of looking at SDF shaders. And it created a really nice thing. Now, the important part about this is that it works on curved objects, it works on straight objects, it works on shapes, it works on really anything that people want to use in the level. So it empowered design to go through and do exactly what they wanted. And they never had to come back and say, can we do this? It was like, no, go ahead, use it. It's cheap enough, it renders nicely. So the last bit about this that's really, really important, because right now it just looks like a UI shader, is everything, and that one doesn't really show up, but that's okay. Everything had to work in 3D. It was all 3D UI. It had to be in the space. You had to be able to look at it from an angle. It had to be able to animate and do everything, and it can't lose quality. So this ended up being a great way that TechArt was able to come in, provide a nice UI solution where one didn't really exist. So another good way that TechArt helped to kind of push forward. These are all slightly graphics related. I like to call this out just because it's ISS astronauts playing RoboRaid on the ISS. But I laugh about it sometimes because it's empowered me to say that I helped international astronauts fight aliens in space. And I can put that on my resume. So moving away from RoboRaid, I'm moving quick here, but there's plenty of time to talk after, is we worked on Windows Mixed Reality. And Windows Mixed Reality is a VR product that we released, I think, a year ago. Windows Mixed Reality, in that we created what we call the Cliff House and the Skyloft. Those are two user experiences where you get to have your own house, your own space. You get to go in there, put down 3D objects, put down 3D applications, put what we call slates, which are 2D applications, into the space. You can leave in there, go away, come back, everything's still there. So it's really your own house that you get to live in, your own space to live in. So for this was had to be a multi-room space, had to be performed across quality tiers, and that seems obvious, but what I mean by that is we were targeting a non-existent part of the VR market. So we were targeting extremely low PC down in the integrated GPU market. So we were targeting a little bit of a different area. It was similar probably in performance quality to some phones, so it's not too unheard of. And it had to be relaxing, personal, and productive. We had a brand new engine editor system, so we had a lot of different tech artwork to kind of catch up on. And we, of course, started with performance, because all these things were new. So on performance, we went from the 200 rule to the 400 rule. Generally, if teams worked with 400 draw calls and 400,000 verts, it was on screen at one time, not in the level. It was an acceptable system. And so it allowed the design team and the tech art team and the art teams to go off and prototype tons and tons of work. We went through probably 30 or 40 different levels before we landed on Cliff House, and experimentations around how much space do you need for an app? What's the right size? What's the right distance? All sorts of different things. Meanwhile, while we're doing these prototypes, the tech art team is building up tools, we're building up pipelines, we're figuring out source control stuff with the rest of the team. Obviously, tech art didn't do all that, but we're working with that to figure out how do we take the team, provide solutions that allows them to iterate quicker. If we can iterate quicker, we can reach either higher quality, quicker finish dates, things like that. So this is the inside of the Cliff House if you haven't seen it. And in the top left, we have it's a multi-room creative space. So there was a larger room there near the bottom of the image, which was supposed to be a place you could put 3D objects in the space, items up on the walls. There was a smaller nook up above it, which was supposed to be more of an office space where you could have a little bit more intimate connection to your software. In the bottom left, we have it's kind of a transition space between two rooms, but it was a little bit of a nature space that you could put things down. And then on the right, we have two images of the same room, which is what we called the movie room. And the movie room had a button on the wall, or has a button on the wall you can press, and the walls will animate away. So you can go from an intimate viewing space to a large kind of IMAX viewing space that you can put your apps. On the outside, we had roof space, which was accessible through different stairs, in a backyard space, which people could go out and same thing, they could put things wherever they want. We're from the Seattle area, so we put a picture of Mount Rainier in the distance. The important things on this is tech art went through, like I was saying before, we helped identify different pipeline things. We also worked on grass shaders, we worked on foliage shaders, we worked on terrain shaders, built out different pipelines so that the creative team could go through and really try to build whatever they wanted through both the design of the shape and through the visual elements of the shape. What you kind of not really see is in the top right, you can see there's also an ocean out there. And so we have ocean waves, we have trees with leaves falling off of them, we have a bunch of different systems. The other level we worked on was Skyloft, and we had similar goals with that, which was it was supposed to be multi-room, performant across the same quality tiers, personal, productive, and focused on multi-app. Now the focused on multi-app is an important difference in if we want to go through and have a user space where they can interact with an app, what about interacting with multiple apps? We do that on our computers all the time. Many of us probably have multiple monitors. How do we have that in VR? What are the differences? What are things that we might do? So again, we went through, did a ton of different prototypes. There's a few things that I wish had made it into the final product that I could talk to you about because I think they are really good design learnings, but they're not there yet, so I can't quite talk about it. But you can get an idea from it. In the top right, there's a big black wall up in the upper part of the image. It's this multi-panel wall where you can go and put things on. It sounds like it's a multi-monitor, but really actually it allows quite a bit more. So if you have a chance to try out Skyloft, go in there, experience it, try to put some things up there, and then walk around the room. Get a sense of it, because you never really walk away from your monitors at your desk. And so there's some interesting interactions about being close and far. You can see different graphs again in the top left image. We had some better reflection systems. There's glass walls, so we had to deal with transparency, any sorting issues on that. It's a little bit of a simpler space, which is nice, especially for performance, but there was a lot of time spent on visual quality polish. We had already dealt with the engine pipeline stuff, so we kind of had some time to play with a little bit of just finesse. So some of the areas, like where did tech art help? All the different areas I talked about with pipeline and shaders and accelerating the team, trying to reduce our iteration rate, trying to increase quality, making sure that we don't have big burn rates at the end. TechArt can be helpful in a lot of ways. Another area that TechArt had helped was MRTK, which if you saw June Park's presentation, MRTK is Mixed Reality Toolkit. And Mixed Reality Toolkit is an open source toolkit that while we've been building HoloLens and Windows Mixed Reality, we've been trying to get people to work on the MRTK. And the MRTK is available for Unity. It's on Git. You can download it, you can contribute to it, you can file bugs on it, and it's there to do what I kind of talked about with our team, about what we did is it's there to accelerate your team. Lower your iteration values, get things out quicker, get to your ideas faster, and then decide what you want to keep or change. So it has buttons, it has voice input, controller input, hand input, gaze input. It has all these systems in there and built really quickly and easily for you to use it. That's about it. There's a link to MRTK if you want to try and check it out. Otherwise, I have about a minute for questions, and I'm available after if you want to talk. Thank you.
Anyone? Thank you so much.
Thanks.
Okay, so it's working now again. All right, thank you so much, Philip. Does anyone have any questions for him? Sure.
Thank you. So this is, you're probably not going to answer this, but next version of HoloLens, is it upcoming?
HoloLens is important to Microsoft. That's about all I can say.
Okay, that is an answer. It's not a good answer, but.
And I think we have one more quick question that I could do. No? Okay. Thank you so much again.
Sure.
It was really
Yep.
great.
Have a good day.